Welcome to The Explainer. Every single time you stream a movie, fire off an email, or even just browse a website, you're using a network. So today, we're going to pull back the curtain and look at the actual physical hardware that makes all of that magic happen. We're talking about the core components that are quite literally the building blocks of our digital world.
But have you ever really stopped and wondered about that? How do all of our devices, our phones, our laptops, and those giant servers somewhere far away that power our favorite websites, how do they actually talk to each other? It kind of feels like magic, right? But it's not magic, it's all down to some really clever engineering.
And the answer is they do it through a network. And every single network, from the little one in your home to the massive ones that run global companies, is built using a specific set of hardware called network components.
So here's what we're going to cover in this explainer. First, we'll define what network components actually are. Then we'll break down the specific jobs of three key players: the server, the switch, and the firewall. After that, we'll get practical and see how they all work together in the real world. And we'll finish up with a quick recap and some exam practice to get you prepped.
Okay, so let's start with the absolute basics. What exactly are we talking about when we say network components?
All right, here is the core exam-ready definition you need to know. Network components are the physical hardware items, the actual boxes, the cables, the circuits, that you need to build a network that actually works. A great way to think of them is like the postal service for your data. Their job is to handle everything, from sending and receiving those digital packages to controlling the flow and making sure they get to the right place. That's a really crucial idea to lock in.
Okay, let's dive into our first major component, the server. We've all heard the term, but what does a server actually do?
Well, a server's main job is to provide something that could be services, data, or applications to other computers on the network, which we call clients. The whole idea is centralization. It puts all the important stuff in one place. It works on a really simple request-response model. So your computer, the client, requests a web page, and the web server responds by sending it to you. Simple as that. And servers can get super specialized. You've got file servers for storing shared documents, web servers that host all the sites you visit, and media servers that stream your favorite movies and music.
Now, what's so cool about this image is the sheer scale of it all. See, a server isn't always just one lonely box sitting in a corner. Not at all. Big companies use what's called a server farm. These are huge warehouses, just packed with servers, all working together. These data centers are the real powerhouses of the internet, handling millions upon millions of requests at the same time.
All right, let's move on to our next piece of the puzzle. If a server is the service provider, then the switch is the local traffic director. Its job is to manage how data moves around inside a local network, like the one in an office or a school.
So the official definition tells us that a switch is a big improvement on an older, dumber device called a hub. The key difference here is intelligence. See, a hub just shouts data out to every single device that's connected to it. A switch, on the other hand, is much smarter. It actually looks at the address on each little digital packet, or data frame, to see exactly where it's supposed to go.
And that's the crucial point right there. A switch is like a smart postal sorter inside a single office building. When a message comes in, it doesn't just yell it down the hallway for everyone to hear. No, it looks at the name on the envelope and delivers it directly to the right desk, or in our case, the right computer. And this makes the entire network way faster and way more efficient because it cuts down on all that unnecessary noise. Okay, now for a component that's all about protection, the firewall. The best way to think of it is as the security guard standing at the front gate of your network.
And a diagram like this one is perfect for showing how it works in a more complex setup. See, a firewall inspects all the traffic coming in and going out, pretty much like a bouncer at a club checking IDs. This diagram shows a pretty sophisticated setup that uses two firewalls to create something called a demilitarized zone, or a DMZ. What this means is the public can get to the web server, which is in that middle zone, but there's a second internal firewall that adds another layer of protection for the really sensitive stuff, like the company's internal database. Very clever.
Okay, so we've looked at the individual parts. Now for the fun part. Let's put them all together and see how these components actually solve real-world problems for modern businesses.
Let's kick things off with something we all use constantly, an online store. I guarantee you every single time you buy something online, these components are working like crazy behind the scenes. Think about it. The website itself, that lives on a web server. Your account details, your order history,
All that is kept safe and sound on a totally separate database server. Inside their data center, you've got switches that connect all these servers together so they can talk to each other super fast. And maybe most importantly, a firewall stands guard, protecting your sensitive payment details when you hit buy. They all have to work together perfectly for that transaction to happen.
For a second example, let's look at something really relevant today. A modern hybrid office, right? Where you've got some people at their desks and others working from home. This whole way of working is only possible because of smart networking.
So you've got a central file server, often a little box called a NAS, or network-attached storage, that lets everybody access the same shared files, no matter if they're in the building or on their couch. Back in the office, a switch connects all the physical gear, like desktops and printers, and the firewall is doing double duty here. It protects the office from outside threats, and it creates a secure encrypted connection, what's called a VPN, for all the remote workers to use, which keeps all the company data safe.
Okay, I know that was a lot of information, so let's boil it all down to the absolute must-know points. Seriously, if you're revising for an exam, this is the part to really tune in for.
Let's do a quick run-through. Number 1. Network components are the essential hardware of any network. Number 2. Servers provide services to clients. 3. Switches direct traffic inside a local network. And 4. Firewalls protect that network from threats. If you can remember those 4 points, you have got the foundation totally covered.
Now let's do a little practice. Here's a pretty typical exam question for you. Describe the role of a server in a client-server relationship. Go ahead, take a second and think about how you'd structure a really good answer. Okay, so for top marks, you'd want to define what a client is, what a server is, and then clearly explain that request-response cycle we talked about earlier. And here's one more. This one's focused on security. How would you explain the use of a firewall and a DMZ to protect a database server? Right, for this one, you'd need to remember that two-firewall diagram. You'd explain the job of both the external and the internal firewalls and how that DMZ acts as a buffer zone, separating the public-facing services from that super secure internal network.
And finally, here's a thought to leave you with. In today's world of cloud computing, where companies are just renting servers and storage from giants like Amazon or Microsoft, which of these components, the server, the switch, or the firewall, do you think it's most critical for a company to manage and control themselves? And maybe more importantly, why? It's a really interesting question when you think about where all this is headed.